So we want to calculate the improper integral from 0 to 4 of 2 over x minus 2 dx. And we see that our integrand has a point of discontinuity at 2, which is why this is an improper integral, because 2 is in our interval. So what we're going to do is we're going to split this into two separate improper integrals. The first one is going to go from 0 to 2 of 2 over x minus 2 dx. And then the other one, we're going to break up on the other side of the interval, 2 to 4 of 2 over x minus 2 dx. And now each of these are an improper integral because they have a point of discontinuity at 2, which now is at the end. And so now we're going to turn these into proper integrals with a limit. So we're going to be looking at the limit as b goes to 2 from the left, because we're coming from inside the interval, of 0 to b, 2 over x minus 2 dx. And very similarly, I'm going to use a different letter here because I don't want to keep reusing d. Let's use a goes to 2 from the right. And then we got a to 4 of 2 over x minus 2 dx. So what we have now are two proper integrals with limits. We can now do the proper integrals using our fundamental theorem, and then we'll take the limits afterwards. Now the reason b is going to 2 from the left, we'll think about our interval. We have the interval from 0 to 2, so we're heading to 2 from the left. Very similarly over here, a is going to be towards 2 from the right. Now, we're going to take the antiderivative, and the antiderivative of this is 2 natural log of the absolute value of x minus 2, and that's going to go from 0 to b in this case. Limit as a goes to 2 from the right, 2 natural log of the absolute value of x minus 2, and this is going to go from a to 4. So now we're just doing our fundamental theorem and putting in our limits, and then we'll take the limit to get our final answer. So we have limit as b goes to 2 from the left, and we'll plug in our limits now. So we have 2 natural log of the absolute value of b minus 2 minus 2 natural log the absolute value of 0 minus 2 plus limit as a goes to 2 from the right of 2 ln of the absolute value of 4 minus 2 minus 2 ln absolute value of a minus 2. Now we got to put these parts in parentheses because we're taking those limits. This one didn't need it, but for some symmetry, we'll put it in there. All right, we've got some constants in here. So we have the limit as b goes to 2 from the left of 2 natural log of b minus 2. So that's going to be a limit we have to evaluate. This part here is just going to be a constant. So minus 2 natural log. 0 minus 2 is negative 2. Absolute value is 2. So that's just a number. Plus. Now we don't need to take the limit of this first part. So let's just write out what it is. 2 natural log of 4 minus 2. So that's once again 2 ln of 2. We could combine those. Those are going to cancel. And then we have this other limit part. So minus limit as a goes to 2 from the right of natural log of a minus 2. These will cancel. Really, it all comes down to calculating the limits. If these both limits exist, then we have a convergent improper integral. If either one of them diverges, the whole thing is divergent. So we need to see what the behavior of ln of b minus 2 is as we approach 2. One way of doing that is by graphing it. So here we can take a look at the graph. Here's ln of absolute value of x minus 2. And as we come in from the left, it goes to negative infinity. Well, as we come in from the right, it also goes to negative infinity. So in both cases, these limits are going to go to negative infinity. And again, all we needed was one. Once this thing went to negative infinity, we were done. This improper integral is divergent.